Many people have heard of Bitcoin, that it's a fully digital currency with no government to issue it, and that no banks need to manage accounts and verify transactions, and also that no one really knows who invented it. And yet, many people don't know the answer to this question. Mining, I mean an actual direct description of what the computers are doing when we send, receive, and create cryptocurrencies. The difference is that the backbone underlying this is not a bank that verifies transactions. Instead, it's a clever system of decentralized trustless verification based on some of the math born in cryptography. The way this works is that everyone generates what's called a public key-private key pair, each of which looks like some string of bits. The private key is sometimes also called a secret key, so that we can abbreviate it as SK while abbreviating the public key as PK. Now, as the name suggests, this secret key, it's something you want to keep to yourself. In the real world, your handwritten signature looks the same no matter what document you're signing. But a digital signature is actually much stronger, because it changes for different messages. It looks like some string of ones and zeros, commonly something like 256 bits, and altering the message even slightly completely changes what the signature on that message should look like. Speaking a little more formally, producing a signature involves a function that depends both on the message itself and on your private key. The private key ensures that only you can produce that signature, and the fact that it depends on the message means that no one can just copy one of your signatures and then forge it on another message. Hand in hand with this is a second function used to verify that a signature is valid. And this is where the public key comes into play. All it does is output true or false to indicate if this was a signature produced by the private key associated with the public key that you're using for verification. I won't go into the details of how exactly both these functions work, but the idea is that it should be completely infeasible to find a valid signature if you don't know the secret key. Specifically, there's no strategy better than just guessing and checking random signatures, which you can check using the public key that everyone knows. Now think about how many signatures there are with a length of 256 bits. That's 2 to the power of 256. This is a stupidly large number. To call it astronomically large would be giving way too much credit to astronomy. In fact, I made a supplemental video devoted just to illustrating what a huge number this is. Right here, let's just say that when you verified that a signature against a given message is valid, you can feel extremely confident that the only way someone could have produced it is if they knew the secret key associated with the public key you used for verification.